We are back again, this time with a little bit of measurements. I was asked about the power consumption. So in standby reset and at 224 volts, I see 11.4 watts. Let's try and crank it up to 230 is the standard voltage in Denmark at least. So that is 12 watts of standby. I put this dial for 100 range and then set to 10 point almost 0. So now when I go out of standby to meter voltage, be careful. The click is not going to shock you. So now all of the high voltage parts is now active and we got about 10 volts of output. And current consumption is 17.5. And most of that power is that resistor down there. Don't touch them because there is a lot of voltage. So this is the power consumption in this range. In this range, it doesn't matter which output you have. You can crank this all the way up and oh yeah, okay, I actually see. So this is 99. This should be actually 100, right? So I'm reading almost 100 volts of output, and in this setting my current consumption is now 18. So what we should try and do and go back to 5. Okay, I think I should go back to 100, right? So when I crank this up now, one more go. This is the dangerous range, okay? So be careful. And I did double check. My meter should handle 1000 volts of DC. So now it's going to be exciting. So this is 100 dot, so that is 100, right? And that is about right. And it's still the 18 watts of input. So that was 100, 2, 3, 400, and I'm reading on the meter, yes, we got 400. See, voltage is going up, or power is going up. 500. So that's 24 watts of idle. Now we're going to 600. 700. And 800. 900. And 1000. I wanted to say that the whole day. It's because it's 1000. And yes, it is nearly 1000. So that was the power consumption. And yeah, that was all I wanted to show in this video actually. Line regulation. I only performed the test at 10 volt. Because I really don't care about any of the other settings. As long as it passed 10 volts, I should be quite happy. So what I've done is I take my meter and I clear the readings for 230 volts and then this is 230, and then I go down to 207. 207 should be minus 10%. Like that, right? And then I just give it a few seconds. So it's 7.6 microvolts. So this is just the normal noise. All right, so we go back. So that in this setting, I should expect 30 microvolts maximum. And then I go back. And then we see again. So this is 230 again, and we are still a span of 15. So this is half of the accepted span. And then we go all the way up to 253. This is plus 10% as well. And again, I should be able to accept another 30 microvolts of span, and the total span should be under 75 microvolts. But now my total span is still under 75. And what you see here is actually just a little bit of temperature, noise, or regulation. So I passed the line regulation test. UB. Load regulation. It says the current limit should be fully clockwise. So this is maximum allowed current. They say 400 ohm resistor. I don't have that, so I have 390. But that should be within the accepted tolerance. So from open to 400 ohm load, the maximum accepted variation is 30 microvolts. So again, what I do is I clear the settings and see that I have at least 2 samples. Let's take a little bit more. Okay, so we have a few microvolts of well, this is just the noise, right? So now I connect the resistor. Now it is connected. Ooh, oy, 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 oy. See what we have here? We have a span. Maybe it was the noise from me touching, because I think I still read 05, right? So 30 microvolts should be 3 counts here, right? Let's try and clear again. And then remove the resistor. See? The 2.7, that is the noise. And then, whoops, you see we are back again. So I think this spike is just me touching the connector. So that is, of course, something that I shouldn't calculate as an error. But now I have 98. Ooh, that is actually a little bit out of spec, isn't it? That is bad. So now it's open. And then I connect the resistor. So 98 it was. And then back to 05. So that means I am out of spec here. The regulation is not good enough. So now we have to look in the manual. What is the cause and the solution?